Okay, so for now we are going to talk about lenses, but before that we have to take a refresher on what refraction is, because if mirrors work by reflecting the light rays, lenses work by refracting the light rays. So if you remember, refraction happens when a light ray enters the boundary of two transparent materials such as air and water. So say here you have a light ray, and that light ray crosses the boundary between the two media. So what happens is we can draw a normal line. Remember a normal line? At the point at which the light ray hits the boundary. Okay? And instead of the light ray going straight, like this, instead of the light ray going straight, okay, that does not happen. This does not happen. What happens is the light ray bends. It changes direction. In this case, it will bend toward the normal line. So it will bend a little bit closer to the normal line. So instead of going straight, the angle is going to be changed towards the normal line. So now the light ray would travel like this. I hope you can see that it changed its angle. So instead of going straight like that, it bended towards the normal line. Okay? Now, as it enters another boundary from water to air, because this is air, water, and air, it again bends, right? As long as it enters the boundary at an angle, it will again bend. But this time, it will be doing the opposite of what it did here, which is instead of going towards the normal line or bending towards the normal line, now it will bend away from the normal line. So if I will just have to draw the normal line first. So the normal line is here, right? It's perpendicular to our boundary. So now I will draw the trajectory if it did not bend like that. That's the straight path. Now the light ray will actually move away from the normal line. So this is the normal line. So it will not bend like this, but actually sort of slant up a little bit. So the light ray is going to do this. Okay, I'm just going to do some cosmetic work here because I think my light ray is a little bit crooked, but I meant a straight line. So see, as it enters the boundary from air to water, it bends towards the normal line. As it enters the boundary between water and air, it bends away from the normal line. And that happens only when the light ray hits an angle between the boundaries. Okay? So if you have a light ray that is moving straight, perpendicular to the boundary, parallel to the normal line, so like this, you have a light ray like this. Okay? So there's no angle. I mean, the angle between the boundary and that light ray is 90 degrees. And it's parallel to the normal line. There's no angle between the normal line and it. It will just go straight without bending. And also here, go straight without bending. Okay? So refraction only happens when the light ray hits the boundary of two materials at an angle. So with that, we can now move on to discussing your lenses. So if you have a plain, say, piece of glass, so you know that there are different media here. So here you have air, and then as the light enters the glass, so the medium is glass. Then as it exits, it is also air. It's again air. Now, if we have this shape, it will be the same as this, wherein it's from air, enters the water, and goes out of the air but the angle is 90 degrees. So the light rays will just pass through and they will just be straight, just like how they entered the plain glass before. However, when you shape the glass differently like this or like this, something interesting happens because this light ray here goes straight, center. This one also goes straight, but the light rays that are above and below it are not going to go straight, because if you notice, as they hit the boundary, they are not hitting the boundary at a 90 degrees angle, because the surface is not straight. The surface itself is bent or curved. And so what actually happens is here, the light rays would do this. Oops, I might have written an extra light ray. But here, the light rays above tend to be bent to point at the upward direction, and the light rays below will be bending more towards the bottom, right? So you see, you have parallel light rays, then as it exits this piece of glass, they diverge. They are spread out. While in this case, it's a different story, because now here, the light rays will do this instead. Right? So they meet at a, just like the mirror, what did we call this point where all the light rays hit? They meet at a certain focus, right? Now here, these light rays here actually are spread out, but you can also take the argument and you can extend them backwards. And if you extend them backwards, they meet also at a focus. And just like in our mirrors, this focus is a place where real light rays really meet, so we call it a real focus. While this one, you have this focus only because you extended the light rays backwards, so this is going to be a virtual focus. Okay, so that is the basics for your lenses. So this lens is what we call, well, just based on the shape and based on our discussion of the mirrors, this is what we call a concave lens. Take note, we are now talking about lenses, not mirrors. This is a concave lens. And this one is a convex lens. So, just like the mirror, you can also think about it as the light rays hit this side, that side has a caved shape. So that's why we call it a concave. And this one is convex because it's bulging, right? So the bulging part is towards you. So this is a concave lens, this is a convex lens. So lenses are pretty much just transparent objects that are shaped in a curved way. So if you don't shape that object, the light rays, the parallel light rays will just pass through and they come out as parallel rays. But if you shape them into a certain shape, such as a concave shape, the parallel light rays, as it exits that transparent material, they would diverge such that if you extend them back, you can imagine that there's a virtual focus at the back or at the side of at the side where the light rays came from. In a convex lens, parallel rays hits it and then they converge at a point. So therefore, another name for this things is the concave lens is a diverging lens, because again, it diverges the light rays that enters it. For a convex lens, we call it, please guess. Yes, it's called a converging lens, because if you notice, the light rays are converged. Okay?